Hi everyone. For this question, given that two events M and W are such that probability of M is 0.3 and the probability W given M is 0.5, probability W given not M, you can see this is complement of M, 0.25. So find the probability of M intersect W. So we can get it from our conditional probability. As we can see, conditional probability formula, it will be A given B intersect B over probability B. So for the conditional probability, we can find the point of A intersect B. So we can find our questions here. So for the question A, start with probability W given M. It means that 0.5 here is come with the operation W intersect M over probability of M is 0.5. So after we plug in the formula, then you can notice that probability of M is 0.3. So probability for W intersect M is 0.15. So W intersect M and M intersect W actually are the same thing. So you can answer the question for M intersect W, it is 0.15. Then we can move on for the second questions. Which is find for probability not M intersect W. So we can use the information about not M and W here. So probability W intersect not M is 0.25. We apply conditional probability. This is W given not M. So W intersect not M over probability of not M. So not M intersect W, W intersect not M, they are the same thing. To find probability not M, so probability M is 3. To find probability not M, 1 minus probability M. So from that we can plug in our value. And we simplify this. We get 0.175. Alright, then we are going to find for probability for W. So actually what can we represent from this? We can represent the information of this probability using tree diagram, because you can see conditional probability. Conditional probability means probability W given that N means N will happen first. So our first event is talking about N and not N. Then second event will be about W and not W. W and not W. So after we understand this conditional probability means N first. Probability M, probability W given M. So N will happen first. What's your probability of M? 0.3. Not N? 0.7. So this one, probability of W given M. Given N and probability of W, this is 0.5. So not W, 0.5 also. Then you can see probability of W based on, so given means based on not m is 0.25. When this is 0.25, another branches from the probability will be 0.75. Then we can see all the outcome here. The outcomes here, this is m in the set w, this is m in the set not w, this is not m in the set w, and this is not m in the set not w. When we come to question 3, probability to get w. So probability to get the w, it will be probability m in the set w. So where's the outcome? The outcome is here. To reach w, we have undergo these two branches. So m in the set w and probability not m in the set w. And from that, we can read out the probability, which is 0.3 times 0.5 plus 0.7 times 0.25. So it gives us 0.375. Zero point 0.3, so mistake here, 25. Alright, then continue. For question number 4, to get probability, M union with W, we can apply our formula, which is PM plus PW minus M intersect W. So PM, probability of M, which is 0.3, and PW, just now we find this, PW got two cases, 0.3 to 5 minus M intersect. So M intersect W, we get it already. This is 0.15. Then we simplify this. Here we get 0.475. Then next, state the reason why these event of M and W are not mutually exclusive. So you can see, if you want to determine mutually exclusive, we look at their intersection. So M and W intersection is not equal to 0. Therefore, they are not mutually exclusive. So how we show that? We will give the main characteristic for mutually exclusive, where M intersect W is 0.15, which is not equal to 0. Therefore, we can conclude that M and W, they are not mutually exclusive. So when we come to conditional question number 2 here, question number 2 is state the reason why M and W are dependent. So when we have probability M intersect W, which is equal to probability N times with probability W, this is independent. So when it's not independent means dependent, it will be not equal. So we can obtain the result that where we can see the intersect here is 0.15. If we take probability of M times with the probability of W, probability of M is 0.3 times with probability of W, which is 3 to 5, where we find this one. So you can get this 0.0975. So you can notice that their multiplication is not equal back to the intersection probability. So they are not equal to the multiplication of the individual event. Therefore, this is the case where M and W are not independent, or we call it dependent. So that is how we prove the special case here, whether mutually exclusive, C intersect, is it in 0 or not. If intersect 0, mutually exclusive. Not 0, not mutually exclusive. Then we see the intersect here, is it multiply of individual event? If you get same, means it is independent. When you get the value does not same, means the two case here is dependent. So that's all for this question. Thank you for watching.